Hi, I'm Nick Burlinson, and I'm a final year mechanical engineering student at the University of Newcastle, and this presentation is a part of my Science and Professional Communication course. Today I'll be talking very briefly about the aerodynamic properties of a plane's wings, as well as the importance of the angle of attack of an aircraft. Now, the theory of aerodynamics has been around for hundreds of years. The theory of air resistance was first developed by Isaac Newton back in the 1700s. And then in 1799, the four main aerodynamic forces of flight, being thrust, lift, drag, and weight, as well as their relationship to each other, were first identified by George Clayton. With these forces, the thrust, which is provided by the engines, and the lift, which is provided by the wings, have to overcome the drag caused by the air resistance, as well as the weight of the aircraft, in order for the plane to successfully fly. Now, the wings generate lift by causing the airflow to deflect under the wing. Now, this creates an area of higher than average pressure below the wing, as well as an area of lower than average pressure above the wing, and this creates a net effect of an upward force on the wing, which creates lift. Now, the angle of attack of an aircraft is the angle between the wing of the aircraft and the oncoming airflow, and it involves a trade-off, as a greater angle of attack will deflect more air, which creates a greater pressure differential and therefore generates more lift. However, it will also expose a greater surface area of the wing to the oncoming airflow, which therefore creates more drag and will slow the aircraft down. When designing an aircraft, a very important consideration is the critical angle of attack. Now, as the angle of attack is increased, the airflow along the upper surface starts to become separated from the wing. And once the critical angle of attack is exceeded, it causes the airflow to become completely separated, which leads to a loss of lift, and due to the high air resistance, will cause the plane to stall. Now, all aircrafts have their own individual critical angle of attack, but it's usually between 15 and 20 degrees, depending on the design of the plane. And it's critical that a pilot knows this angle in order to avoid the plane stalling. And also, many modern aircraft now have inbuilt systems which will automatically prevent the aircraft from exceeding this angle. Now, thank you for listening to me, and hopefully I've given you a basic understanding of aircraft aerodynamics. Thank you.